Okay, we gotta draw a picture for this one. So, right triangle with A, B, and C. Try and make the hypotenuse always C. So, we call these other ones A and B. So, this is side A, this is side B. Okay, theta is sandwiched between the hypotenuse and the side A. So, here's theta right here. And the sine of theta is 3/16. So the sine is opposite. That means B is 3 and C is 16. Okay, another right triangle has sides that are doubled. So 2 times A, 2 times B, 2 times C. So I'm going to draw maybe the same picture, A, B, C. Okay, so 2 times A, this is 2 times whatever A is, and this is 2 times B, but I know B is 3, so this is going to be 6, and 2 times C, this is going to be 32. Okay, now phi, they want you to put phi in between the hypotenuse and the side, same spot, so put phi right here. And if phi is there, they want to know the sine of phi, so the sine is going to be, sine of phi is going to be the opposite over the adjacent. It's going to be the same thing. It's going to simplify down to 3/16. So, a good question would be if they would have asked the cosine. So then you would have to find A using Pythagorean's theorem and then double it over on the other triangle and then find the cosine. Okay, 10. So this is the unit circle. So the radius is 1. Pi thirds. Pi thirds, remember pi thirds, that, I mean, you can go pretty quick. 180 over pi. Pi thirds is the same thing as a 60-degree angle. So this is 60 degrees. The cosine, that's where your theta is. Your theta is right here. Your theta is always from 0, 0. So they want the cosine. Cosine is just adjacent over hypotenuse, so it's 1/2 over 1. So it's just 1/2. So they should have asked you for like the sine. So you have to find this piece right here. So that's a pretty good question. 11. What is the value of the sine of 5 pi over 2k? First of all, move number 1, change that to degrees. So 180 over pi, and pi is cancelled. 2 goes into 180 90 times, so 90 times 5. So that's going to be 450 degrees. So that's more than a circle. So I'm going to take away a revolution, and that leaves me with 90 left over. So 90 degrees. Okay, now 90 degrees, as you open up to 90, so remember, so if I have a radius, and let's say this radius is 10, and I'm swinging it around and around and around and around, the closer I get, and it makes a triangle, the closer I get, that's the height of my triangle, and then this is the base of my triangle. And the closer I get to swinging it to land right on 90, so here's my 10 right now, my height is getting taller and the base is getting smaller. But, okay, now this height, this is always, here's theta right here, this is always the opposite piece. And your base is the adjacent piece. And then the hypotenuse, that's your hypotenuse. So they want sine. They want opposite over hypotenuse. Alright, so the opposite. If I swing this and land it right on 90, it's going straight up and down. So that means my radius, which is the hypotenuse, is going to be 10, and my opposite is going to be 10 also. So it's going to be 10 over 10, and that's the same thing as 1. Okay, number 12. C is 90 degrees. Okay, so the cosine of A. So the cosine of A is going to be adjacent over hypotenuse. And that's the same thing as the sine of B. So if I put the cosine of A is equal to the sine of B, that's a true statement, because the sine of B is going to be the opposite over the hypotenuse. And then let's use the sine of A. So the sine of A is going to be equal to the cosine of B, and that's true for every right triangle. So the sine of A, if you were to do sine of A, that's going to be this guy right here over this guy right here. And the cosine of B is equal to adjacent over hypotenuse, the same two pieces. Tangent of 5 pi over 3, so change 5 pi over 3 to degrees. 5 pi, so let's just times it by 180 over pi. Pi's cancel, 3 goes into 180. 60 times 5 is 300 degrees. 300 degrees is going to end you up almost back to a 360. So my initial piece always starts at 0, 0, and it lays flat right on the x-axis. And then my terminal piece is going to be right here. So if I rotated 300 degrees, that means this angle, which is what I'm going to put theta, that's where we're going to do the trig, that measures 60 degrees. Okay, now to make a triangle, you got to go back up perpendicular and make a 90 degree. And if that's 60, this is 30, so it's half of an equilateral. Here's my other half. Always flip it over the 30, make up your own dimensions. I want this triangle to be a 10 by 10 by 10. So that means this piece is 5 and this piece is 5. And the height of it is going to be 5 times the square root of 3. But it's going to be negative because it's going down. It's going below 0. It's going in a negative direction. Okay, the tangent. Tangent is the opposite over the adjacent. The opposite is negative 5 square roots of 3. And the adjacent is 5. And so you just have a negative square root of 3. So you got to draw a triangle out, show your work. And on this one we're going to have to draw a picture. So Matt and Katie are flying kites. String of Katie. Is extended 864 feet. So let's pretend that's her hand. And then that's the kite right here. So that piece is 864. And her kite makes a 38 degree angle of elevation. So here's Katie. That is going to be 38 degrees. So it's going to rotate 38 degrees from above off the ground, and then the wind takes it. So your triangle, there's your 90. Okay, Matt, let's see, Matt's is 725 feet. And his is open a little bit steeper, so his is 40 degrees elevation from the ground. Okay, draw a diagram. So we got to find the altitude. We need to find the height. So we got to find this and this. So we're going to put theta. Theta's right here. And this piece is the opposite, and this piece is the hypotenuse. So we need to use the trig function sine. So the sine of 38 degrees is equal to the opposite over the hypotenuse, 864. So now to solve for x is pretty easy. Just undo the division. Times both sides by 864. Times this by 864. So on your calculator, do 864 times the sine of 38. I'll make sure I'm in degrees. Okay, 864 times the sine of 38, hit enter. So that kite perpendicular to the ground is 531.9 feet. Matt's kite, so it's not as far out, but it's on a steeper angle, so let's see where how far his is off the ground. So sine of 40 degrees is equal to x over 725. So times both sides by 725. 725 times the sine of 40. So Matt's is 466 feet off the ground. Okay, determine the area of the triangle. Now area is 1/2 times the base times the height. So one of these two sides needs to be the base, and I'm going to make 20 be the base. So the base is 20. So 1/2 times the base, I just need the height. Okay, the height of this triangle, if 20 is my base, I don't know what I did there. Okay, 20 is going to be my base. So the height has to go and hit my base. So it's got to go from B and it's got to drop straight down. So I've got to extend my base out. So it's going to go from B, it's going to drop straight down and hit your base. So I need to find this piece right here. And you're looking at a 90-degree triangle, and you can do the trig on it. You know that this is 13. You don't know this, but you do know the angle. The angle's got to be 70 degrees. And 70 degrees and 110 are supplementary. They had to be 180. So I need this. And I can find that. I can do the sine of 70 degrees. And that equals opposite over adjacent. So if I do 13 times the sine of 70, 13 times the sine of 70, that means my height, this height, is 12.2. So I'm going to take 1/2 times the base times the height, which is 12.2, and that is the area. And I get area is about 122 centimeters squared. Okay, last problem. Trevor built a wheelchair ramp. Here's some specs. Calculate the ratio of the vertical rise to the horizontal run. So the vertical first, 2.5. To the horizontal run, 37.5. Write your answer as a fraction in the lowest term. So if I just type that in on my calculator, it'll simplify it for you. So 2.5 on top, 37.5 on bottom. Oh, it gave me a decimal. So I want to convert that decimal to a fraction. And that fraction is the same thing as 1/15. 1 to 15. Okay, so to satisfy safety requirements, the ratio cannot be greater than 1/12. So the question is, it cannot be greater than 1 to 12. Is 1 to 15 going to exceed, 1/12, and cannot exceed 30 inches. The ramp can't exceed 30 inches, so that's the hypotenuse. That's what we don't know. We got to figure out what that is. So first let's figure the length of the ramp. So the length of the ramp is just going to be a squared plus b squared is c squared. 37.5 squared plus 2.5 squared equals c squared. So then I'm just going to do the square root of that. So I'm a calculator, let's go square root of 37.5 squared plus 2.5 squared, and that's 37.58 feet. Oh no, I'm an idiot. The rise cannot exceed 30 inches, not the ramp. Okay, the rise can't be greater than 30 inches, so the rise is 2.5 feet. So 2.5 feet times 12 inches, and that is going to be holy cow, 30 inches. So it does not exceed 30 inches, so we're safe there. So this is exactly 30 inches. But it cannot exceed a ratio of 1 to 12. And we are at a ratio of 1 to 15. So I think we're safe. Because 1 to 15, if you change that to a fraction, or to a decimal, that's 0.06 forever. And 1 divided by 12, if you change that to a decimal, that is 0.08. So it cannot be steeper than a ratio of 1 to 12, can't be bigger than 0.08, and our ratio is 1 to 15. 15 is bigger than 12, but it's in you're dividing by it, so it's kind of opposite. So our number is smaller than 0.08, so we're safe, we're good in both areas. It's not greater than 30, and our ratio does not exceed 1 to 12. So calculate the angle of incline. They want theta right here. So theta, I'm going to use opposite over adjacent. So I'm going to use tangent. Tangent of theta is equal to 2.5 over the adjacent. That's 37.5. And now I need to find the angle, so I need to do the inverse. I need to do the inverse tangent of 2.5 divided by 37.5. So that is about a 3.8 degree, somewhere around there. That's the angle of incline.